Yes. There we go. All right. All right, this is Dr. B here, and welcome everyone. It's so good to see everyone here again. In the chat, drop who's here tonight and where you're from so I can see what's going on. This evening, we are going to look at converting moles to molecules. So before we looked at molecules, I should say we looked at moles to grams using the molar mass, but tonight it's all about moles to molecules. This is something that kind of messes students up a lot when they have it on an exam, and you will see this on exams and quizzes. So let's jump over there and get started. I have to admit I'm a little bit sleepy tonight. It's been raining all weekend long and kind of feeling like just a little bit sleepy. So hopefully cognitively I'll be acute here tonight so I can get these problems correct. So keep me honest. Let's go over to the screen. And here we go. All right, I lost my chat. There it is. Yeah, Nivas is here. Jason's here. Excellent. Brenda is here. Lots of folks. Excellent. So what we're going to do is we're going to convert moles to molecules or atoms. So often what we say is we call those particles. So a particle is like an atom or a molecule or an ion. In this case, we're going to convert from moles to atoms. And what's great about mole conversions to atoms or particles is we don't have to worry about molar mass. All we have to do, multiply by Avogadro's number. Hey, Bryce. Good to see you here. So let's do this one. We'll go 0.75 moles. I'll do the first one, and then I'll have you guys do some. And because we're going from moles to something, we multiply, hopefully that helps you remember, by Avogadro's number here. So 6.02 times 10 to the 23rd, and here the particles are atoms. So we're just going to write atoms in here. Let's move this down. And when we multiply, it's atoms per mole. So this many atoms in 1 mole. Multiply the top, moles cancels out. And here's the thing that students have problems with. They see this 0.75 and they're trying to multiply it by this big thing here. All you have to do, multiply 0.75 times 6.02. That'll give you 4.5. And then just bring the 10 to the 23rd down. And the units are going to be atoms. All right, so we're multiplying our moles by Avogadro's number, units cancel out, and we end up with atoms. So you guys ready to do one? All right. Here you go. Convert moles of calcium hydroxide to particles. So in this case, we'd say formula units. Molecules would be one way to say it. And I'll give you this up here. Give it a try. Nivas, you ask if I can teach physics. I don't usually teach physics. I like physics, but I usually stay pretty much in chemistry, maybe some maths here and there. Remember, you don't need to worry about molar mass when you're going from moles to particles. So remember, we're going to multiply by Avogadro's number. So when we do the multiplication here, moles on the top and the bottom, so they're going to cancel out. And you can think of it this way too. If you want to use factor label method, you could just put a line all the way across here and put the line like that here. And this is particles per 1 mole. You could consider this over 1, right? So now again, your moles cancel out. You're left with particles and Bryce is estimating. It's actually hidden by the thing. And we got Jason saying something here. I end up, when I do this, 1.33 times 6.02, I'm getting 8.05. And just bring this part down then, times 10 to the 23rd, and we'll call it particles, like that. So because I have 1, 2, 3 here and 1, 2, 3 here, I wanted to have 3 in my answer. So Jason, I see you rounded it, but it's probably better to keep those digits consistent there. That's pretty much it. That's pretty much converting from moles to particles. You multiply by Avogadro's number. Let's do another one here. So sometimes what teachers will do is they're going to try to give you extra information that you don't need. That's kind of a classic test-taking thing. So whenever you have molecules, moles to molecules, or molecules to moles, you don't need to do the molar mass. That's only from moles to grams. So just so you're remembering that, teachers will try to trick you whenever they can. All right. So give this one a try. And Jason, you ask whether it's 6.02 or 6.022. You see it in the books a lot with 6.022. I just like 6.02. I don't think it really changes much. But if your teacher's really into that, that's what you got to go with. Yeah, I'd agree that math, chemistry, and physics are kind of the same thing. There's a huge amount of overlap. I would say math is the purest kind of form of inquiry. Physics tends to be pretty close to math. And chemistry, you got kind of some more conceptual things in there that aren't necessarily always mathematical. All right, we're going from 3.20 moles. So Jason, watch out with those numbers. And you could just multiply like that, or you could try to get a little fancy here and do some factor label or dimensional analysis. Draw that out there. Call it per 1 mole. So moles is gone. So 3.20 times 6.02. What did I get for that? I ended up with 18.2 times 10 to the 23rd. But I see some other, Jason has 19.3. So I could be wrong. Like I said, I was pretty tired, but 3 times 6 is 18. So particles. But here's the thing. When you get that answer, it might be a good idea to take it to scientific notation. So what you can do is if you move this here, you've made this smaller. So we'll just make this one bigger. And you could call it 1.82 times 10 to the 24th. That's the same number. This is just more scientific methods. Scientific, not method, but notation here. All right. How are we doing? Hello, New Beginnings. Thank you. So how are you guys feeling about moles to molecules? Have you had enough? You get the idea for that? It's a little more challenging going back the other way from molecules to moles because of those exponents. So that's really what I'd like to show you how to do next. Because if you can do that, then you're pretty much done. Oops, this one, this one's a little tricky. Let's go here. Perfect. All right. Here you go. So when we go from moles to molecules, right? You're going to multiply, but you're going from molecules here to moles. So now you got to divide. So I'll do one and then let you guys do some, just so you see how we could do this. 12.2 times 10 to the 23rd molecules. So then I need to divide that by Avogadro's number. So I'm going to pull this over here. And you kind of see the problem. How do you divide these big exponents, right? So if they're the same, you can just cancel them out like that. And now it's 12.2 divided by 6.02. And particles and molecules, that's the same thing. So we'd have moles would be our final unit. If they're different, you just subtract them. So here we end up with, what do we end up with? This is 2.03 moles. 2.03 moles. So that kind of works like that. Yep, and Jason, you got it there as well. So give it a try. Give this one's a try here. Molecules, let's go to moles here. Let's not do liters. That's a little more work. There we go. Molecules to moles. I'll put this in here if you need it. Cathartic redundance. That's very interesting. All right. So you could do this what we did before here. You could just put this underneath and divide by it. And that would work. Particles would cancel out and we just divide. So here I would subtract 14 minus 23. 14 minus 23, that equals what? -9? So I divide 21.2 by 6.02. And I'd end up with, I'm going to do that on my calculator here. 21.2 divided by 6.02. That gives me 3.5. Call it 3.52. And since I have this here, when I subtract those, I end up with 10 to the -9th. And that's going to be moles, because that's all that's left. Yep, and Jason, you getting it the same thing? Yeah. So since we've canceled out particles, we end up with this here. So that's the key. You can still just divide these two numbers here, and then you subtract, and that's what's going to give you your final answer. Yeah, not too bad, right? Try one more here. I'm going to change this. We don't need to do grams this evening. Let's take it to moles. So try this one here. I think that may be all I have tonight. You guys kind of we just cruised through this here. Yeah, Nevis, what didn't you, oh, you want me to explain it again? Let's do this one here, and then if that doesn't fix it, we'll go back and look at the other one more time. Oops, something bad happened. Occasionally that happens with this program. It just does whatever it wants. Let's put this over here. There you go. All right. Yeah, previous question. So I'll go back to that in a moment, Nevis. So I'll show you two ways to do this. Hello, Mixo. So you can do what we did before, where we cross the molecules out. So we'd have 0.232 divided by 6.02, and then we'd subtract these numbers. So 36 minus 23, that's what? That's 13, a positive 13. So what do we get here? I get 0.385. I hope that's right. Times 10 we subtracted to the 13th, and that's moles. Then if you wanted to change it, you could move this here. That would make this bigger, but then we have to make this smaller now by 10. So that's what I end up with. 3.85, 10 to the 11th. I'm ended up with 10 to the 12th, Jason, but I could very well be wrong. So let me show you one other way to do this, and then that'll be it for tonight. I'll go back and look at the previous question as well. One other way you can do this, and this may be how your teacher, Nevis, I'll go back to that in a second. So your teacher may want you to do it this way. So they may want you to take, and instead of dividing, multiply by a conversion factor. It's the same deal, right? It's the same math. It's just with the conversion factor, we know that we have molecules here. So we need molecules on the bottom. That means that we'll have moles on the top. And we know that 1 mole is Avogadro's number. Try to squeeze it in. So we can multiply by the conversion factor. We multiply and then we divide, so the molecules cancel out, but you're still dividing by 6.02 times 10 to the 23rd. It's no different, just sometimes they want you to set it up this way. So just wanted to show you that. So yeah, Jason, that is true. 36 minus 23 is 13. I just wanted to show you that sometimes you'll see it done that way as well, right? Molecules cancel out, J Boogie, that's key. I think I got something wrong. Jason, okay. So let me go back up to the one before, and we'll go over that again. Someone asked me to do that, and yeah, I'm going to get rid of all this stuff here. Actually, most of this stuff here. I'm using a program called Inkscape, and it's a free program, and it's kind of neat to write with. So if you're interested, it's free. It's open source, Inkscape. I think it's inkscape.org. So that's where I got it from. So for this problem, we're going from molecules to moles. So we divide by Avogadro's number. So that's how I set this problem up. Then since you have molecules and particles, they're the same thing on top, cross them out. Then I'm going to divide these numbers here. So when you divide these numbers here, you'll get, I can't remember what we got, 3.52. Then I'm going to take the exponents and subtract them. So 14 minus 23, which I think we said was 9, negative 9. So that becomes the exponent, the negative 9 there, and that would be moles. I think that's right. Yeah, that looks... So that's how we do that. I hope that helped explain what we were doing there. The other way you could do this one is you could use the conversion factor and have things cancel out. Lots of teachers like that. It's nice. It works for a lot of other things as well, not just what we're working with here. So yeah. So I hope that helps. Oh, now you got it. Excellent, Nevis. I hope that helps everyone with this molecules to moles thing. It's not too bad once you do it, and once you get subtracting the exponents if you need to do that. That's, as a student, that's what messed me up, was subtracting those exponents really caused me a lot of headaches. But once I got it, no problem. So I think we're going to end it up at this point tonight. This is probably like the 8th or 9th stream I've done. I'm still kind of finding my way with this. So any suggestions are always welcome. You can just leave a comment on this video that will show up on my channel. Leave a comment, any suggestions, or you can email me directly if you have some suggestions. I'm going to put it up here on the screen. What is my email? Dr. B at Breslin. Breslin's my last name. .org. Dr. B at Breslin.org. Yeah, I don't actually give my phone number out on the internet because there's too many strange things that happen on the internet here. Oh, and let me give you this guide here. I gave it out last time, but let me put this in the chat. This is a free guide I made for moles to grams and grams to moles, moles to molecules. So there it is. You guys are welcome to it. I usually just give that out to members on my channel, but you guys are welcome to have that. We've done some good stuff tonight. All right. I think that's it. I'm going to end the stream, and then I'll stick around in the chat for a few minutes, and then I'm going to go to bed. I'm like still feeling sleepy. Yeah, Wings on Fire, the dimensional analysis or factor label, that's a good way to do it. It's all the same math, though. Nothing really much different going on there, just the way you set it up. But teachers like dimensional analysis. All right. Thank you, everybody. I'm going to end the stream and just hang out in the chat for a few minutes. I'll be back on Tuesday, same time. This is Dr. B, and thanks for watching.